Good afternoon, everyone. My name is Rahul. I welcome you all for the webinar on industrial cybersecurity solution for OT infrastructure. This webinar is organized by Sarla Advantech Private Limited, which is ATS India, along with the Bayshore Networks. So I will just give a couple of minutes for the attendees to join. So we'll just wait for a couple of minutes and then we'll start again. Good afternoon, everyone. My name is Rahul. I welcome you all again for the webinar. So we'll be beginning. My name is Rahul Kulkarni. First of all, regarding that, like basics about this webinar session. So all of us has joined this webinar over the tool called GoToWebinar. So here the webinar will be presented by Sarla team as well as Bayshore team. And all your questions and everything you can type in during the session anytime. So there is a question option is provided to all of you. So you can type in your questions there, and we'll be taking these questions at the end of our presentation and demonstration. So we'll be doing that. And now we start with our webinar with the introduction. So first slide is of introduction. This webinar is arranged by Sarla team along with the Bayshore Networks. So here we have Mr. Vibhor Jain. He's our sales leader from Sarla. He sits in Delhi office. So he's a main primary contact for all the sales related activities for all the Bayshore products and services, everything. So my name is Rahul Kulkarni. I basically looks after the pre-sales things about solution designing along with the marketing activities for ATS India. Then we have our guest, Mr. Mahesh Garde from Mahindra and Mahindra from Pune office. So he mainly looks after the IT MES things from the cybersecurity activities. So he'll be also sharing his thoughts about what challenges the industry is facing today and all. And then we have a team from Bayshore USA. Mr. Toby, he's a chief product officer there with the Bayshore network. He will be mainly talking about all the products and solutions which are available on the cybersecurity. And then we have Mr. Philip. So he will be mainly showing you the practical examples, the architectures, along with the demonstration of the product. So this is how the today's session will be conducted for next 1.5 hours. Now the next point is about the index. So these are the major points which we'll be covering up. First, we'll be having the introduction about the Sarla, and then the importance about cybersecurity will be covered by Mr. Mahesh from Mahindra. And then we'll go in detail about the product, what are the product portfolios are there, in the architecture, use cases, and we'll have a demo session for one of the product. And then at the end, we'll have question answers. So you can type in your questions anytime in between. So we'll take it one by one at the end. So yeah, so that's a session. So as a first, I invite Mr. Vibhor to start up about the introduction with Sarla. So Vibhor, please.
Thank you. Hi, good afternoon, everyone. My name is Vibhor Jain. I'm from CERDA Private Limited, or we call it as ATS India now. So we'll start with a brief introduction, what we do, who are we. So we are into this manufacturing IT solution for more than 20 years now, and we have experience in automation software, manufacturing integration projects, MES projects, MOM projects. We are serving manufacturing industries along different verticals. These are pharma, chemical, metals, mining, energy, automotive, aerospace, infrastructure. Also, we have long-term association with the leading software solution partners like GE Digital, SAP, Verum, Capfair. So GE Digital has primary product portfolio for SCADA solutions like iFix, Simplicity, Historian solution, Plant App solutions. Capfair Technologies is a US-based company which are majorly into driver development, and they have 150 plus set of protocols available with them to get connected with your PLC systems or devices which are available within the manufacturing environment. SAP, we are the implementation partner for their particular module, MI, Manufacturing Intelligence and Integration. And we have a couple of installations in India and overseas too. Verum are particular into MES domain for pharmaceuticals company. They have a product called PASEX, and we are the implementation partner for the particular product PASEX in India. Also now we are the part of ATS Global, which is a Netherlands-based company since 2018. Okay, and we are the we have trusted relationships with the leading manufacturer across India. We do a lot of OT IT integration projects with these leading manufacturers. Also, we are 9001 2015 certified company. As on date, we are 450 plus satellites. We have 15 offices across globe. Out of 6 offices we have in India, our HQs in Navi Mumbai and development center at Ahmedabad and Bangalore. We have 150 plus customer across manufacturing sector, and as on date, we have done close to 2,500 plus installations across India and globally. So this is the brief about CERDA or ATS India, what we do, who are we. Okay. Then, since this webinar is based out at cybersecurity, what is cybersecurity, what is OT security, I'll cover the brief points related to cybersecurity, what is OT security, why OT security is important, and why CERDA and Bayshore are coming together to bring this product line into an India market. So typically what we understand by cybersecurity, or typically what we understand by the word security. So I would say in layman language, security is defined as being free from danger, or we are feeling safe. Typical example for security would be like we are at home and our doors are locked and we feel safe or you feel safe. So when it comes to cyber security, it's a state or process for protecting or recovering your IT and OT assets from any type of cyber attacks. The IT assets can be your computer system, network devices, programs, etc. And OT assets can be your PLC system, VFD systems, your SCADA systems or DCS systems. So why this OT security is important? What is the use of OT security? So typical OT assets, what we understand by OT assets. So typical OT assets includes the SCADA systems or PLCs we have in plant or in manufacturing environment. We have VFDs, we have DCS systems, we have safety systems. And these OT assets are used to control your manufacturing environment or your power plant, your power stations, your cement plants, or your chemical plant or any of the pharma plant, or maybe your public transportation also. As this technology is growing day by day and networked all around, so we need this OT security. This is the requirement in today's world. So this is the essential thing we need to secure our OT assets. So coming to the point, why OT security is important. So most of the manufacturers across India or globally, and we as a partner, we are working towards this industrial IoT things, industry 4.0 things, big data analytics, smart manufacturing, digitalization, which requires this IT and OT combinations to deliver right information to the right people at right time, and that too in an understandable format. So we at CERDA we are privileged to work on this IT and OT integration projects across different manufacturing sectors in India. So as an also these industrial systems become day by day, these industrial systems are become more connected and more integrated, and so they are more I would say exposed to threats also, or cyber threats also with this current pandemic, this work from home situations also. We need to give our systems to our vendors or to our software suppliers for modifications or configurations of something. So there are a lot of questions which comes into our mind or our manufacturing partners' mind. Since our PLCs and SCADA systems are connected to web server, do they face any security risk? Is there any security risk with that attached to it? We need to give this remote access to our systems, of our systems to vendors and suppliers. How safe it is? Is that safe enough? We all know nowadays we have this IT infrastructure in place, and is that IT infrastructure is sufficient enough to handle this OT security systems, OT assets? Do we need to do something more for this OT systems or OT security? So this all brings in the need of this OT security or cyber security, and this high, all know the cost of industrial equipments are too high, downtime cost is too high, and in turn the financial costs are too high. So we need to protect our industrial OT systems, and we need a more robust solution in and around of this OT security. So this brings in why Sarla and Bayshore, why we thought of bringing a solution around OT security or something. So we were also looking for a right solution for this, and we find Bayshore is a perfect example or perfect solution for this. So Bayshore is the perfect solution for this OT security and everything. And I would like to highlight few points regarding Bayshore here. So first unique point with Bayshore is it's a purpose-built solution for OT security and OT protocol like OPC and Modbus. Okay, and second thing about Bayshore is Bayshore focus on preventing an attack. Bayshore has much more advanced positioning as compared to other several solutions who focus on network visibility and analysis. And on the top of it, this endorsement is directly coming from the leading OT vendors like GE Digital and Yokogawa. They have appreciated Bayshore technology, and they are working in depth with Bayshore to adopt this technology in their products. So as mentioned earlier, also being Sarla a leader in IT OT integration solution in India and Bayshore best OT security solution provider, we decided to came across and we decided to work together to serve our Indian customers. So this is from my end. Thank you, and over to you, Rahul, now.
Yes, thanks a lot, Vibhor, for this introduction and basic requirements. So next now we'll move on to Mr. Mahesh from Mahindra. So he will be mainly presenting you with the all the challenges he are facing or the practical experience from his side. What is the typical requirement from manufacturing is there? Mahesh, please share your thoughts.
Thank you, Rahul, for giving me opportunity to speak on this very important topic. So, hi, good afternoon, everyone. I am Mahesh Garde, working in Mahindra & Mahindra organization as a manager in manufacturing IT. So, before I could start talking about OT security and its challenges, let's have a quick introduction about manufacturing IT. So, at manufacturing IT, we are responsible for manufacturing execution system, that is MES, then OT network, in which we are taking care of control network at each shop floor from IT hub room to the machine network switch. Then we have carried out some industry 4.0 initiatives like machine connectivity with visualization dashboard, then energy management, and finally machine analytics. So where we are mainly dealing in both OT and IT network. So considering all these ownerships, the industrial cybersecurity and production critical data security are the most important factor to us. So here a question may arise, why manufacturing should consider OT security? As you all know, manufacturing sites are changing day by day with IT-OT convergence. And due to it, shop floor devices and equipments are now exposed to new threats that we had not even thought about earlier. And the kind of devices PLC that we use in OT environments are not built with security aspect as a design element. So when we are connecting these devices with the IT network, connectivity use cases, industrial IoT, all of these will introduce our manufacturing sites to so many different threats. And if you do not have the right framework, the right security in place to fight those, the impact will be very severe. There could be a direct production loss. And as you know, OT space covers wide variety of products, PLCs, SCADA, DCS, and RTU, etc. And these are supplied by many vendors and having very long life cycles. Many of them are absolute, but still we are using it. And the exposure of these absolute components to the IT world has a security concern. Thus, any cyber attack in OT network has a direct effect on manufacturing facilities. So far now, I spoke about why the OT security is very crucial for manufacturing environment. Now let's have look on some of the biggest OT security challenges in manufacturing plant today. So here I have mentioned top 4 security challenges in manufacturing. So let's talk on one by one. So number 1 is standard compliance. Most of our manufacturing units are finding it very difficult to comply with standards that we need to follow. That is IEC 62443, then IEC 27001, and NIST standards. So it is becoming very challenging for us to train our resources to follow right processes and modify the approach for implementation across the different standards that we need to comply with. Second one is a security assessment. The security assessment and being able to counter the new threats that are being introduced in our OT environment. This only is also bigger challenge to us because in manufacturing we cannot having downtime for any critical activity. Production is running in very strict schedule, and squeezing our network security assessment activities in that period of time becoming really challenging for us to accomplish. The next challenge is security threats inside network. As we know, an average life of any malware in OT environment is expected to be at least a few years. And unless we have a right monitoring environment in place, we won't be able to detect these threats before they actually get activated in our network, and thus can cause a lot of damage to our manufacturing. So real-time monitoring system is very much essential for us. And the last challenge I would like to mention here is the threats inside network. What does it means? Let's have an example of any employee or vendor who's having significant access to control network, and they can do any collateral damage by targeting the controllers. Many due to some human error like misconfiguration to the controller or loading a wrong program code inside the controller, it can be happen. All of these can cause production stops and it is impactful as a cyber attack. And after a failure, it is difficult to detect what caused the disruption. Was it a cyber attack or human error? There is a lack of visibility. Based on all these challenges I talk about, I would like to add some of the experiences we faced related to OT security. The first one is in our engine plant, maintenance team has used unmanaged network switch to connect PLC and various devices to the Mahindra network. But one of the engineer unknowingly connected network cable in wrong port of the controller. So because of it, looping error occurred in OT network. And it was difficult to understand exact device which actually caused it. So we check one by one all devices connected to the Mahindra network and we kill that issue. But it kills our time and does affect the production. Also, in second point, we have some legacy operating systems. We have some legacy machines which are running on Windows XP operating system. So antivirus and Windows patches updating is not happening to this system. And we faced WannaCry attack to one of them. So currently we are connecting such type of systems through firewall. The next challenge that we face is wrong PLC code download. We also face the issue of wrong PLC code getting downloaded accidentally in running production PLC while working in test PLC. And the last and the most important is the current scenario of COVID-19, most of us are working from home and taking remote access to the system from outside of the plant, which is a big threat to the OT network. So in my next slide, I'm going to show you unsecure flat ICS network, and attack paths. In this slide, you can see a typical unsecure flat industrial control network where OT and IT network are interconnected with very less security controls. In this slide, it can be clearly seen all the challenges and security threats in typical unsecure OT network and their possible attack paths. All these are security threats which can be seen from the architecture and can compromise our industrial control network. These are insecure remote connections, infected laptops connected to our network, then misconfigured firewalls, insecure wireless access switch, infected USB connected to the control network, or any PLC logic which got infected, or any third-party laptops, vendor laptops which are connected to our network. So in this case, considering this architecture, OT security is most important. Here I am coming to the end of my presentation, and let's conclude what I talked so far. Earlier, most of the threats that were known from IT world, now the hackers are also coming up with the threats which can directly affect our OT environments. The hacker will sit in our OT network, they will learn from our network, and over a period of time, they will actually start working on it. So it is impossible to fix this kind of threats unless we have the right system in place for monitoring, managing threats in real time. Thank you. Now I'm handing over to Rahul again. Thank you, Rahul.
Yes, yeah. Thanks a lot, Mahesh, for this wonderful explanation about the challenges what you are practically facing at Mahindra, and so it is really helpful for us also for everyone to understand what the challenges and everything at the shop floor. So now, as a next part, I'll be handing over to Mr. Toby. He will be giving more details about actual products from Bayshore. So he'll be also introducing all the products and portfolios there. So over to you, Toby.
All right. Very good. Thank you. Thank you, Rahul. Thank you, Mr. Mahesh. We really do appreciate the opportunity to speak with everyone this afternoon. My name is Toby Ware-Jones. I'm the Chief Product Officer for Bayshore Networks, and I've been working in the information security industry in one way or another for about 23 years now. My goal for this afternoon is to really, I think, reinforce the message that's already been delivered, which is that this is a problem that will make a fairly significant impact to just about every industrial environment. And I'm starting with just some samples, a small selection of companies that have been impacted by industrial cybersecurity events already just this year. And the U.S. government publishes a series of emergency response advisories about vulnerabilities in products or descriptions of attacks against particular companies. And as of yesterday, there have already been 457 of these alerts just this year. So we're already on track for somewhere probably double or triple the total number by the end of this year that were reported in 2019. And there's no discrimination on industry vertical. There's no discrimination on whether or not a particular activity is considered more high profile. The reality is that just like we saw on the IT side, beginning 15, 20 years ago, attackers can afford to look for any vulnerable network, any vulnerable device. And they don't care at the beginning where it is necessarily. There are, of course, also targeted attacks, but the sort of bulk scanning and discovery of vulnerabilities is so easy and inexpensive for an attacker to do that there's really no pre-filtering for most of this type of activity. And it affects the industrial OEMs as well. The classic model for industrial equipment assumes that even in a digital transformation scenario, that network is somehow isolated. But the reality is they never are. They have connections to enterprise networks. They have connections for third-party suppliers to get in and perform maintenance. They have wireless access points that were installed temporarily and never removed. And so the message is not to decide whether or not you think you are at risk, but as Mr. Mahesh said, to understand that you have a responsibility to reduce the obvious ways you can already be attacked. And the consequences can be, of course, tremendous. And the recovery from these attacks when we're dealing with industrial systems is particularly difficult because it affects real product. It affects manufactured goods that come off of a conveyor system. It affects the quality of drinking water that comes out of a water plant. And there's no alternative but a long and difficult cleanup and recovery, which is obviously a safety risk for your customers, very expensive. And we do encourage people to bear in mind that if you use any sort of connected device, if you make use of any sort of conventional networking architecture, again, I cannot emphasize enough, the issue is not whether or not you are exposed to these risks. The issue is simply when your particular network will fall under the surveillance of dangerous activity. Bayshore, as we heard earlier, Bayshore is a pure play industrial cybersecurity solutions company. And this is important. The techniques that are required to protect an industrial network and to be sensitive to the operating principles of an industrial environment are different from the sort of traditional approaches that we use on the enterprise or IT side of the equation. As a result, Bayshore has put together a portfolio of 4 separate products, and I'm going to introduce all 4 of them to you during the course of this afternoon. And then my colleague Philippe Panier is going to show you some working demonstrations of how these solutions come together. But the thing I'd like you to remember as I present these products is that the core engine that powers them, the Bayshore policy engine, is the result of over 8 years of invested R&D, research and development, from our senior engineering staff. It is a difficult problem to do the things I'm going to describe, and it is not sufficient to believe that because you have a Cisco firewall, which is a sort of classic IT solution, or another IT security product, which happens to know about some industrial buzzwords, it's not the same class of solution. And I'm going to try and emphasize some of the differences as we go. So the 4 products, just moving across the left to right, NetWall, OTFuse, OTaccess, and Scrutiny. These are all intended to solve different use cases, different particular requirements inside a typical industrial network. And so we'll go through all of them. I guess the introductory comments I'll make here are that what's important in these solutions is understanding which use case you think is most important for you. You'll hear me make reference to the strategy of segmentation. And in many cases, we've noticed that industrial networks tend to be relatively flat and permissive, which means that once you get in access to one part of the industrial network, you can probably see just about everything throughout that network. And this is an opportunity for a segmentation strategy. And segmentation means delineating which part of the network a given device and the traffic it generates are able to connect to by default. So it exposes certain parts of the network to be accessible and to be able to be interacted with, but other parts are concealed. Now, implementing network level segmentation traditionally requires you to replace and upgrade the network. And so it's difficult and expensive and time consuming. But the first 2 products I'll talk about, NetWall and OTFuse, their real advantage is they allow you to pick and choose a segmentation strategy and carve out sections of your network in a single effort and assign a highly secure protected segment to assets within that part of the network. OTaccess is a secure remote access solution. We recognize, and again, Rahul spoke about this earlier, the reality nowadays with the COVID, but even prior to that, is that it's not realistic to expect that the personnel who need to do work with a device will always be at the site where that device is located. They may be your employees, they may be your customers, they may be your suppliers, but enabling safe remote access is an important part of making these assets do more for you and to get a better return on your investment. And then finally, scrutiny is a software tool that we provide, which is intended to really help with baseline network hygiene, understanding what you have, what it's doing, and then being able to evaluate your progress as you move through addressing some of the older devices or the older cleanup items that require attention. So with that, let's go into a bit more detail about each of the products. NetWall is what's called a unidirectional gateway. And you can see there are two actual physical devices in a NetWall deployment, and this is by design. So it's a two-server solution where one server, the blue server, is connected to a trusted network. And devices on that trusted network, we have a need to get information from those devices. They might be databases, they might be SCADA systems, they might be IoT sensors. But we have a need to get that information from those devices out of their network. What we don't want to do is allow any kind of inbound connectivity from the external network where the data needs to go. And so a unidirectional gateway is designed to enable that. And NetWall is our solution to this type of problem. And it's innovative for two reasons. The first is it does not use modified optical connections in order to enable its transmission. Instead, we use a very high performance PCI connection between our two servers. It supports up to 40 gigabits per second of throughput. And when a rule is configured that allows a device on the blue network to replicate, we receive the message for that data on the blue server. We disassemble the incoming network connection. We move the content across that PCI bus, and then we reassemble a new network connection to deliver the data to the specified destination on the other network. And so what that's allowing is a very robust network isolation, or if you prefer, a network segment, where the protected network is one segment and the receiving network is another segment. And we are enforcing content-based traffic controls and permissions via the rules in NetWall to ensure that only the very explicit data can come from the blue side to the red side, and that there's no return path of any sort for devices on the red side to communicate back into the blue network. And this is what allows it to be a unidirectional gateway. Now, there are some traditional devices that try to do something similar, and they make use of this optical style interface that I mentioned before. The challenges with those devices are really threefold. The first is they use proprietary custom hardware, which is very expensive. And that but inevitably results in a sort of cost challenge for the products. For the amount of bandwidth that you can purchase for your budget, you're generally going to be you're going to look to spend an awful lot of money in order to buy that device. The second challenge is related to flexibility. Because the unidirectional optical system is by design very limited, there are practical restrictions on how much data and what types of data and how many simultaneous data flows you can support across an optical gateway device. So again, the first restriction is sort of the cost of the customized hardware. The second restriction is flexibility. And the third restriction is ultimately to do with the devices themselves, the form factors, we'll say. One of the major advantages of NetWall is that we can offer 3 different performance tiers with the same hardware. We can offer 50 megabits per second, 100 megabits per second, or a gigabit per second of bandwidth. But the hardware in all those cases is identical. So if you start off with a 50 megabit NetWall device and your needs expand and you find you need more performance, you don't need to replace the device. You simply need to acquire an updated license key, which is a simple software file, and apply that license. And now suddenly your NetWall will be a 100 megabit device or a gigabit device. Similarly, if you're stocking inventory or spare parts, again, there's only one part number to worry about. So it's very simple and flexible in terms of accommodating customer growth. So the advantages, I think, are really important. We support replication for all the standard sort of industrial use cases: SCADA tools, database replications, file transfers, streaming sensor data. We can do all of that sort of replication from the trusted networks to the external networks. But we do so with a much lower price point. In general, it's roughly 1/3 the traditional optical-based devices. And with tremendous flexibility in terms of ease of use and ease of expansion as you move into the higher performance devices. And this is really the essential advantage. We want this device to become a preferred choice, not just for the very, very high end of the market, but for the mid-market, the section of the market that recognizes the benefit of robust segmentation and isolation. But for whatever reason, the traditional hardware gateway devices simply weren't applicable. And now we believe that with the NetWall product, we've made them more accessible because they are so much less expensive and so much more flexible to use. So I'll move on to the next device now, which is the OTaccess product. So OTaccess, in terms of industrial sort of network layouts, OTaccess is really our endpoint protection device. And the intention here is that, as we heard from Mr. Mahesh, the PLCs themselves are really the sort of valuable devices at the end of the line, which are controlling the critical machines. And so we don't want to require a customer to change anything about the actual machines doing the work. What we want to do is offer an add-on solution which can wrap around the existing network, the existing tools, and be used by the existing staff with their skills, but provide a significant increase in the type of security that's offered. So OTaccess does exactly that. It's a simple inline industrial security appliance. And the way it works is you connect it literally inline on the network connection between the cabinet where your equipment is and the upstream part of the network. And the first thing it does is automatically learn and build rules that it suggests based on the traffic it sees. So it looks at all the interactions between the PLCs and the workstations and the historians and the HMIs and all the other critical devices. And it organizes that traffic according to the industrial protocols that are being used. So, OPC, Modbus, Ethernet IP, there's a whole list of them. And it further classifies that activity into one of three categories: read-only instructions, read and write instructions, or programming instructions. And based on those three categories, it suggests rules. So you don't need to know how to write a rule, a firewall rule or a router control list or any other sort of networking rule statement. You don't need to know a thing about it. You interact with this device purely through a graphical interface. And the rules that it suggests, you can of course refine. So you might update details about the rules. You might recognize that during the learning period there were certain things that are normal on your network, but they didn't happen while you had the device in learning mode for one reason or another. And eventually you decide on those rules and you switch the device from learning mode into monitoring mode. And during monitoring mode, it will show you any other traffic which isn't accounted for by the rules that it has already built and that you have refined. And that is essentially an indication of potential anomalies. Now, you may discover that, in fact, some of those anomalies are legitimate and you want to account for them. So you can add them automatically with one click to the set of rules on the device. Or you may confirm that there was activity that you don't want to impact your PLCs. And so you're going to leave those unaccepted. Finally, you switch the device into protection mode. And the difference now is that any of those anomalies that arrive will be blocked. And they'll be blocked automatically. And the important point here is that what we're trying to do is ensure that your critical equipment only takes instructions from sources it's meant to listen to, and of a type that those sources are meant to provide. That goes back to read-only, read-write programming. You generally don't want full programming access from devices that don't absolutely need it. That's an an excessive level of permission and access compared to what the business need should be for that device relationship. But you also want a very easy way to change that if there is a temporary maintenance requirement or a scheduled update or something else. And so we make it very easy to elevate privileges, either one time just manually or on a scheduled basis. So if someone has a maintenance window that's every second Thursday at 3 in the afternoon, you can define that as a schedule, and during that window, somebody can do whatever additional work they need with an additional level of access. And this is the critical feature of this device. The rest of the time, for normal activities that are safe and permitted, you don't even see it. It's totally invisible. It's not adding any traffic. You don't need to change IP addresses. You don't need to implement VLANs. You don't need to do anything else. And yet it is protecting a segment of devices in the cabinet where it's installed from any unauthorized or unexpected activity. And that is its critical advantage, is that it does all this very easily in terms of initial installation and setup, and very invisibly. And then two last points that are critical. The first is that if the device itself has a failure, it has a hardware bypass built into it, which means that if it loses power or there's some other problem, the devices behind it in that protected segment are still available to the rest of your network. So there's no risk of the OTfuse appliance causing an outage. The second advantage is that the primary reporting for this device is through your control room and your existing SCADA tools. So the device has its own Modbus server built in, and as part of the installation, we set up a display in your SCADA tools to poll all of your OTfuse appliances and display in real time if there's any anomaly that they blocked and details about those events. And we do also offer, alongside all of this, a standalone management console, a central management console for the OTfuse appliances. So if you end up with a lot of them, you can aggregate all of the learning, all of the rules that they build and suggest, and all of the events that they generate through a single consolidated interface, which you can run in your control room or anywhere else you want to on your network. So we are often asked, how does this device compare to firewalls? And really, there are some fairly fundamental differences. The first is that a typical firewall is at a network edge. It's at a perimeter somewhere, and it's a packet forwarding device, potentially with address translation. So it's terminating network connections and building new network connections and delivering packets, from one side to the other, which the OTfuse product doesn't do. The second difference is we operate, in terms of sort of networking layers, we operate our device as a layer 2 device. So we're not providing routing functions. We're not a switch in the sort of classical sense. We are simply a transparent bridge between the protected assets and the rest of the network. But the final and perhaps most important difference is this deep content inspection, where we're supporting all of these native industrial protocols. We're examining not only the protocol type, but also the specific function codes and payloads that go with them as part of our rule building and enforcement. And that's really the most important difference as far as customized solutions for your existing networks. So OTfuse is really, I would say, just about a unique product available to protect these existing networks, these existing cabinets, and to integrate with your existing control rooms and personnel. And we're very proud to offer it to the Indian market. The third solution I'm going to talk about is OTaccess, which is secure remote access tools. And this is our response to a simple question, which is, how do we enable safe access to critical devices inside an industrial network without exposing anything unnecessary to the remote user? And the classic model is another example of an IT tool that has been repurposed. And that's the VPN that's terminating at the firewall. And we see this all the time. Customers who've been using this, and they come to realize that they've been using a VPN and they connect to their remote desktops, And there's no constraint on what type of access that presents if an attacker were to gain control of it. So OTaccess gives you a very different architecture. It flips the entire equation around, and I'll show you how in a minute. But I want you to remember that we're making use of the same basic techniques that I talked about with OTfuse. We're classifying activity according to function codes. So again, read-only, read-write, full access. And we're constraining in a segmentation strategy what types of access any given service on a single endpoint can receive from remote users. So in a sense, a way of thinking about it is that we are defining a very, very, very precise microsegment for a single service on a single endpoint, and then exposing that to individual remote users. So the way in which this generally works, we identify assets on the existing network. We don't make any changes to the assets themselves. No configuration changes, no agents, no adjustments of any sort. And we have our users somewhere. They can be employees, they can be partners, they can be in theory they could be customers. But the intention here is we want to expose aspects on those endpoints in order to provide access to those users. We use a piece of software inside the network which knows the specific services on the endpoints and opens an outbound tunnel. And this is key. The outbound tunnel means that there is no inbound connection through a firewall to allow any sort of connection inbound. Once the outbound tunnel is connected, we can flow customer data, connection data from the remote users back to those endpoints. And the customer, the operator of the OTaccess server, is assigning policies, read-only, read-writes, full access. If there's a violation, the activity is stopped before it ever enters the network and arrives at the endpoints. My colleague Philippe will show you how this works in a moment. So I'm going to move on just so we can finish out the product overview. The last tool I'll talk about is Scrutiny. This is a free tool. I encourage you all to visit bayshorenetworks.com/scrutiny. You can register to download this tool, and it is an asset discovery and visualization tool. We offer this at no cost because we think that network hygiene should be accessible to every asset owner. So you run the tool as a Windows desktop application. It can ingest live traffic off a switch, or you can feed it PCAP files that you've collected manually. And you run it occasionally, once a week, maybe once a month. You get these structured reports that show you a breakdown of all your assets, the topology of how they're connected, and a summary of all of the connection data based on their protocol usage. And then the next time you can compare the report and you can see what progress you've made. You might decide that you want to, change the access between certain devices. You might want to retire some old servers that are still active on the network. You can choose your particular tasks based on the data that's presented in this report. So again, it is distributed at no cost, and I would encourage you all to check it out. So just to summarize the reference architecture here, we're trying to provide solutions up and down a standard industrial network architecture. So we can see the OTfuse down near the bottom. There's a version of OTfuse that I didn't talk about, but it's also specific to the GE Digital SCADA tools. So the iFix tools, and soon we'll have a simplicity version as well. That works in the control room level, so the level 3. We have the NetWall solution for enabling replication to external networks. And we have the OTaccess solution, which is designed to provide remote access to any of these devices anywhere on the network. And then finally, we have the Scrutiny tool for asset and flow discovery. And I'll just mention briefly that I encourage each of you, if you have questions and you're looking for verification on Bayshore's sort of product set and credentials, you can contact the ARC Research Advisory Group, and they will be happy to discuss, their observations about Bayshore with you, independent from anything that I might have presented today. It's just some simple use cases, and I think we've touched on a lot of these already. The intention is to wrap around a typical production network. So plant control systems, we've got manufacturing devices, we've got control rooms, we've got operators, And I've shown you how we can define those segments and protect all of them using different aspects of the Bayshore solution set. An interesting version of that same idea is a building management system. So this isn't the manufacturing line, but all the health and safety systems of a building or a campus itself. So this is an example that we did for a large data center operator in the United States, where they wanted to control data movement between their individual structures on their campus. The OTaccess solution is in use by a major consumer goods manufacturer around the world. Every one of their manufacturing facilities is connected, and they have over 100 different third-party suppliers now that are making use of it, where the customer still provides full ownership of, defining and permitting access, integrating it with Active Directory. So the important thing here is that they have a single console where they can create and enforce all of their access rules. One of the major industrial manufacturers themselves also uses OTaccess for not only their employees to get to remote manufacturing facilities, but as part of their service agreements to their customers. So when the customer buys a piece of industrial equipment, they make use of OTaccess, or they accept an inbound OTaccess connection from the manufacturer themselves for remote diagnostics and health monitoring. And so they're using the solution for those two parallel use cases every day. And then finally, there's some interesting maritime use cases. So if you think of a large industrial processing ship, whether it's an offshore canning facility or an oil and gas platform, these are self-contained full civic infrastructures. They have to provide power, water, sewer, safety systems, access control, all sorts of different physical systems that you would see. And they typically have a remote access requirement for ship to shore. So we've seen scenarios with combinations of Bayshore solution sets where all of these different solutions are brought together in this sort of isolated maritime world. They have an industrial control room on board where all of these systems are monitored. And of course, they can provide with NetWall some degree of replication of production data or summaries of alerts and incidents, and replicate that over that remote access link back to a remote monitoring facility at headquarters. So there are all sorts of interesting applications for combinations of these Bayshore tools. But with that, I appreciate you listening. I'm going to hand the communications back to Rahul, and I think he's going to shift the presentation over to Mr. Panier. So thank you so much.
Yes. Thanks a lot, Toby, for this detailed introduction about all the products which are available from Bayshore. So as a next thing will be Mr. Philip will be sharing some of the practical architectures along with the demonstration of one of the product. So I will just handing over to Philip now. Philip, please.
Thank you very much, Raoul. So, my name is Philippe Panier, and I'm with Bayshore. And although my real title is sales engineer, I also do a lot of post-sales as well. So my real title is that I do whatever it takes to make things work. So on this, so today we will focus. I will focus on OTaccess, and so there will be two parts to my presentation. So the first one, we will go over some architecture slides, because OTaccess is a very versatile solutions that can be implemented in many ways. So I wanted to give you a taste of the various possibilities that offers to you if you when you choose open access. And then of course the second part will be more of a hands-on demo. I want to show you some screen, how we connect, and we'll actually connect to a real system. So, what you see here on my screen is a very simple representation of an OT network interconnected with an IT network. So we usually use the Purdue framework. So level 1, you would have your PLCs. So level 1.5, that's so you've got OTaccess right there, which is really there to add that level of protection that Toby was mentioning earlier. So it's protecting the PLCs. That's why we call it the lower DMZ, or level 1.5. Level 2 would be your process network. So that's where you find things like HMIs, engineering workstation, those type of components. Then level 3 would be operations. Sometimes I call it's the IT within the OT type of function. So all the servers, the AD would be there, and a bunch of other servers. Then the 3.5 level, of course, is your industrial DMZ. So that is extremely strategic, because this is the delineator between your OT network and your IT network. And then, of course, level 4 and then level 5, that's where you've got the MES, that's where you've got all the corporate network. So when you install an OTaccess system, the first thing you need to ask yourself is, do I want it as a cloud service, or do I want it on premise or on site? Okay, so in the most so we can of course do both. But in its simplest form, you will find that a lot of OT, especially if you're dealing with critical infrastructure, yeah, folks tend to prefer to have their appliances, in-house, so on-site, or also called on-premise. And so OTaccess comes with two components. Toby touched on that a little bit, but I'm going to reemphasize the message here. So you've got the appliance itself, which is right here. So again, normally if it's on site, it will sit, in the industrial DMZ, so level 3.5. So that's one component. And then the other component is the OTaccess endpoint gateway. So let me give you some details about this endpoint gateway. So it's actually a very small piece of software. What it does is you can install it on an existing Windows machine. You can install it on a on a small industrial servers even. If you've got some hardware that's DIN rail mounted or something like that, that would be perfect. It doesn't require much CPU and RAM resources to run. All it does really is to establish a tunnel, and Toby mentioned that, and it's totally right. It's the endpoint gateway that initiates the tunnel towards the appliance. And so this is very key, because the call is being initiated from inside the OT network towards the outside. So you see the firewall, which is here. All you have to do is to configure 443 for HTTPS going out and nothing going in. So it's you got zero connection going into your OT network. So that's really the safest approach. So the next slide. So this is I would say the most fundamental, easiest architecture. So let's complicate things a little bit. So now I still have one site, but I have different processes. You see this part right here duplicates with this part. So that would look like, for example, a DCS, where you've got several processes that are working independently. It could be a manufacturing plant. You got assembly line number 1, so it's got its own HMI PLC, and then line number 2, its own HMI PLC. So it's kind of the same setup. So here, same thing. The appliance would sit in level 3.5, and then because it's only one plant, as long as the endpoint gateway has visibility over all the assets you want to manage, theoretically, you could need only one endpoint gateway. Then the next slide. Now, so we're starting to really complicate things now. So now we are in a multi-site architecture. So you think about, for example, I don't know, a car manufacturer, and they have plants like all over India, for example. All right, so in this case, you would probably have a headquarter here, and you would have your appliance, same thing in the DMZ. you would have for the main plant, you would have your OT endpoint gateway, which will be at level 3, and same thing. So that endpoint gateway would then initiate a tunnel to the appliance. Then side number 2, something's changing. It's interesting. So I still need an endpoint gateway to handle the asset at that plant, but it's recommended to put, of course, this OT, this endpoint gateway in the industrial DMZ, because that guy right here is going to be have to be connected to internet. But then same thing, you see the call, the tunnel is starting from the OT network, so probably via a site-to-site VPN through the internet, and then most likely through the corporate network, and then into the Bayshore appliance. And same thing, so plant number 2, plant number 3, etc., etc. And then your remote users that are over here, they would basically connect so over the internet, most likely to through a corporate VPN. So they connect to the corporate network into the Bayshore appliance. So that's how things would work in a multi-site architecture. So in these slides so far, those are on-site or on-premise installations. So let's see how it works if we have a cloud solution. So Bayshore offers a cloud solution. We are partnering with Amazon Web Services. And so it's a little bit similar, except of course, at 3.5, you're not going to see any appliance because the appliance is in the cloud. So appliance in the cloud, endpoint gateways would be then connected at the level of 3.5, because again, those components would be exposed to internet. So they have to be inside the DMZ. Same concept. Those endpoint gateways initiate the tunnel to the cloud, so essentially to a Bayshore appliance that's being installed, in an Amazon Web Service environment. And so then the remote access users would connect to the Amazon Web Services, and that's how they can get access to the OT assets. So for our demo today, we're going to do the simple one. So this is so the OT here is actually composed of hardware that's located on the East Coast of the United States in our headquarters in Durham. I am actually talking to you from California, so I'm on the West Coast. I'm something like, I don't know, 4,000 or 5,000 kilometers away. So definitely I will be mimicking this guy, the remote access user. So I'm going to use internet. I've got my corporate VPN on. I will be able to connect into the Bayshore corporate network, and then I will show you how to connect to the Bayshore appliance. And then we're going to start seeing something called services, which are basically the flow of communication that goes inside the tunnel. And remember, again, the tunnel goes from the endpoint gateway into the appliance. And so so the goal of this demo, I will show you, and it's going to be very simple. Basically, from an end user, you can connect to, it's going to be either this computer right here or this computer right there. And if we're lucky, we'll be able to do some Modbus data polling as well. So let me now connect to. Okay, so at its simplest form, when you so I'm this guy right here, and I'm basically connecting now to the appliance, to the Bayshore appliance, which is right there on premise. So this is how it goes. So I need to sign in, and I will sign it as admin because I want to show you some cool options. So there you go. So when you log in, the first thing that really strikes you is this word services right here. So you get create a service, view a service, view my services. And you may wonder, well, what is a service? Well, for those of you old enough to remember when telephones had wires, Well, you would go to, if you wanted a phone in your home, you would go to the utility and ask them a telephone service, which basically would be some kind of wire eventually that links your local switch to your home, and that's basically how you would be able to place a call. Well, so a service so the service for Bayshore, it's about the same, but the 2020 version. So let's go over. So if you want to map a service into the reference architecture, the service is in between the endpoint gateway to the appliance. Okay, so I'm going to show you so all the services. So these are the services that I've got available in my demo environment. So I can have some RDP services. So you see the port there, 3389. That's a dead giveaway. Yes, that's a RDP. Ah, that is interesting. So normally the secure remote access would basically provide something like VNC or RDP connection, but at Bayshore we go a little further, and we are able to provide some connection where you can retrieve some OT protocol data. So Modbus is definitely one of them. So if we go, yeah, I think we have time. I can show you what a service looks like. So let's say let's go take this one. There. So I'm clicking on it. So and I will go to edit because there's some interesting information there. So when you create a service, so okay, you give it a name. You say, okay, I want it available from this endpoint gateway. Okay, the site. That is very interesting. So it's in the service that you already specify the account that you will want to open on, in this case, on your Windows machine using the RDP protocol. There's a field called protocol here, which is interesting. So because I am in a what we call clientless, so those are the options. So it's not just RDP. You can do SSH, you can do HTTPS as well. And another one which is interesting, you see this one, enable scheduling, is very interesting. So you could actually say, okay, I want to use my phone only between 9 a.m. and 5 p.m. Well, that's what this button here is going to do for you. Okay, so you can set up a schedule and say, all right, anybody who's connecting and anybody who's authorized to use the service, no matter what you do, it's between 9 a.m. and 5 p.m. And that's really a way for OT people to start being in control again of who is getting inside the OT network. Very important, because the whole idea really with OTaccess is to get rid of those jump servers. I've seen many of those jump servers that that are really sit in between IT and OT networks. And the problem with jump servers is that at some point you are going to have to give the person who connects in, you're going to have to give a login and a password. And so in this configuration here, I do mention the username and the password, but that's when I create a service. So keep that in mind. I'm going to mention that again in a few moments. Okay, so that's services. So I talked about services. What else do I need? I need a user. Sure. So user can be defined two different ways. I can have them defined through the Active Directory. Now that's very interesting in case your customer, in case the people coming in are from corporate, but they could be also local users. So I'll give you an example right here. I've defined some users. So for example, if you had some people doing maintenance, or some some third-party contractors doing perhaps some installation or commissioning. So you could actually create them manually. And you see right here, you can see it's been connected since. So you can have the last time it was connected and some statistics. So again, the idea is when you are the OT manager and you go back to work, or well, you start work from home. And nowadays it's like that, and it's Monday morning. The first thing you want to know is, okay, who got access to my OT network and when? And so that's that's one of the many goodies of OTaccess, is that we will provide you this type of information. So now let's take a a user. So this one, for example, Joe Best, the well-named. So name, etc. But this is important. These are the services that I have assigned to this user. Okay. So I am in charge. The OT guy is in charge. The OT guy is going to decide, okay, this user can only use that service, that service, that service. That user can only see that machine, that machine, that machine. Okay. And now I'm going to do something else. I'm going to connect to the appliance again, but at this time I want to connect as the remote user, because I want you to see what the how the platform would look like as a user. See those two services I showed you in the services. So now they are here. And if we will notice, so if I click on the service, well, I don't get anything. And that's normal, because you don't want to tell the end user what's the login, what's the password of the end machine that you want to give access to. So really the idea is, yes, you will give some access to a remote, let's say Windows machine, to a user, but really the credentials, you keep it within your system, because nobody should know about that. And then, so once this guy Joe Best, so you get connect right here. So let's do it at least once. You connect on it, and there you go. You are now connected into the. So that's I think it's an XP machine, and now you can you can do your work as normal as possible. So that's basically how it would work for an end user. So, and I still have some minutes, so I want to show you something very cool. So this guy, Joe Best, you see, he only has access to essentially an RDP, but I wanted to show you how to retrieve Modbus data. So that is something interesting. If I go back to the architecture, I'm going now to connect to this machine. So it's basically a Windows 10 machine. So it's Windows. And I'm going to connect as admin, and I'm going to show you this OTFuse right there actually has a Modbus server on it, which is great, because if this guy has a Modbus client, well, then I should be able to pull it. Of course, if this computer is not authorized by the OTaccess appliance, then you're never going to see the Modbus data. I think we all agree on that. But because we do have access, and I will show you how to do this, then this machine will be able to go through the appliance and then directly go and get the data from the Modbus web server. So I'm going to show you how this is done. So I think it's this one. There you go. So if you have a, so this is not a clientless solution, obviously. So you've got to have a little client, which is right there. That's the the Bayshore OTaccess. And so I've already opened it, and I logged in, as admin. And so these are the services that I've got available. Now those services, you see the port, of course, is translated, but you see the address. Well, there's no IP address. And as a matter of fact, I don't know the IP address of my Modbus server in this case. If I look at this one, I don't know the IP address of my Modbus server. So that's an added level of security, right? So how do I pull data from a data server? I need a data client. So a Modbus client, I'm sorry. So you go on internet, the QMod master, everybody can get that. If you are interested, just Google that name, QMod master, and you can download it for free. And I've already connected into it. You see the data moves right there. So what is it? Well, it looks like a date, 30th of July 2020. Yeah, because on my time zone we're still on the 30th of July, and yeah, 6:48 in the morning. I think that's the time on the East Coast. See, and so the packets are there. So I think if I go which one is it? It's the monitor. Yeah, there you go. And if you go to the bus monitor, yeah, sure enough, you can see the Modbus transmissions, and you can see the response right here. Okay, so that works because I've got my client open and I logged in as admin, so it gives me a plethora of services that are available, one being Modbus, and that's how I'm able to retrieve Modbus data. So for example, if you had a bunch of, let's say, PLCs, and you wanted to, I don't know, retrieve the data on your laptop, and your laptop had some kind of, let's say, an HMI, and so you need to poll your PLCs with the Modbus data. That's basically how you would do it. And I think that's all I had for you. So Rahul, I think I will give the hand back to you.
Yes, thanks a lot, Philip, for this wonderful architecture explanation, followed by the demonstration of all the points. So now we have seen like all the product demonstrations and the things. So next part is about the question answers and your queries. So we already started getting your queries in. So we'll be answering one by one all those queries. I have along with me Catherine also. So she will be helping me out about the questions and answers. So which you are posting, you can still type in your questions. So we'll try to answer it. So Catherine, maybe we can go through the questions one by one, and we'll try to answer it. So.
Yes, thank you. Thanks, Rahul. Yes, a good set of questions. And the first one I'd like to direct to Toby about addressing legacy OT and unmanaged network challenges using Bayshore technology.
Sure, thank you for the question. I think one of our greatest strengths is that legacy OT environments, we can go into those existing environments and apply solutions without requiring upgrades. We all know that it's expensive to go through digital transformation, and it's not often an option to replace large chunks of your industrial infrastructure. So I would certainly encourage the question, the source of the person asking the question to engage with your ATS team and talk about priorities. Look at your legacy devices and figure out where your biggest vulnerabilities might be, using the guidance that Mr. Mahesh provided earlier, and consider in terms of how quickly you can really make those priorities a reality for you. The OTFuse product, you can buy one and you can apply it to a single cabinet, and you can gain a tremendous improvement in security while learning generally how to work with this new tool. But as I mentioned previously, we don't expect you to need new staff. We don't expect you to learn a lot of new skills. So these legacy environments are ideal candidates for applying Bayshore solutions, and you get to choose, the order and the destinations, and obviously the rate at which they are deployed. So I think you'll find that this is probably one of the simplest ways to improve an existing infrastructure without a huge amount of spend and complexity.
Well, good, thank you. And so the next question is related to what will be the roadmap for running an OT implementation roadmap for running a plant. And for this one, I'd like to refer that to Vibor and the ATS team, because every company has different priorities and it depends, So I would like to turn over how Vibor and the ATS team would consider entering into that conversation with you. So I'm not sure if Vibor has unmuted, but if so, he could take that one on. The question is, if it looks to be that if they wanted a roadmap or some guidance perhaps on OT implementation roadmap, kind of what to do first, how would you handle that?
So we'll take care of this and we'll get back to that concerned person, and we'll discuss specifically on the roadmap and how to take this further. We'll discuss with that person.
Okay, great. That's perfect. There's a question about the OT endpoint gateway. Is that hardware or software? I'm going to direct that one to Philippe.
Sure. So the endpoint gateway, what the deliverable of Bayshore is it's actually a small executable that you run under a Windows environment. So you set it up as a service, and you can install it on an existing workstation. You can certainly install it on a new Windows computer. You could install it on a small industrial server. Yeah, anything that has, and again, I think I mentioned that, but it doesn't require a whole lot of CPU and RAM. So I think if you've got like 2 CPUs and maybe 2 or 4 gig of RAM, it will work just fine. And because it's implemented as a service, so if the hardware happens to power cycle, then when the machine comes back online, then so does the service, and so the tunnel will be automatically reinitiated.
Okay, good. Thank you. I have several questions around firewalling at level 3, and initially, and Philippe, I think this might be good for you. If is there a firewall required at level 3, or why is there one showing? And if we are connecting the OTaccess at level 3, what's the risk?
That's a good question. So if the OTaccess is connected, so first of all, it is possible to connect to install an OTaccess appliance at level 3, or even an endpoint gateway at level 3. But so the gentleman asking is absolutely right. A firewall would be needed. So, but the good thing running for Bayshore is that the tunnel between the endpoint gateway and the appliance is generated by the endpoint gateway. So it's from the OT into the outside. So the basic configuration of the firewall would be this. For the traffic coming from OT to the outside, you need to open 443. And then from the outside to the inside, deny all, nothing. Because the traffic is being originated, it's like a reverse tunnel, essentially. So, so all the traffic is originated from the endpoint gateway into the appliance.
Okay, good. All right, thank you.
Yeah.
So then another question comes up about if our PLCs are in redundant network setup, how could we use OTaccess? And I think probably Philippe, this is also directing to you.
Yeah, I would have to get some. I'd like to have a picture of the of the architecture at play here. If it is a let's see. So I guess the question would be, okay, I guess the question is, if you have a redundant, so you'd have a redundant PLC that has 2 Ethernet upstream going up, I suppose. And if that's the case, then nothing prevents, okay, I get it. Yes, I can see somebody said show my screen. Okay, perfect. So I'm going to take that opportunity. And so in this case, you see several PLCs can actually connect it to a one OTfuse unit via a layer 2 switch. So I suppose, if I get it right, I suppose if you had a fully redundant PLC with 2 Ethernet northbound streams, then I would say if they are connected to some kind of a switch at some point, then one OTfuse appliance would be needed. However, if you don't have the switch here, and if you truly have a redundant path going to the level 2 and level 3, well, in that case, I think a second OTfuse appliance would be needed. And by the way, that's the reason why we've got the central management console, which can sit, that software can sit, at level 3, in the control room, or it could be, so it's really depending on how you're being set up. So the central management console could be inside the OT network, so that would be at level 3, or it could be inside the corporate network, so something like a SOC, for example. And thanks to that central management console, you will be able to manage all the OTfuses in your network.
So I'm going to stop you there, Philippe, because honestly, This one does take a good deal of discussion around the specific configuration needed.
Oh, yes.
So I'd like to defer that one. We'll get back to that request personally. We'll work that through ATS, and we
I'd
will
be happy
touch.
to. Yep, no problem.
There was a question that I'd like to direct to Toby. Does your service support the vulnerability available in OT software? And I'm thinking there it might have to do with known vulnerabilities, and how is it that we track that? Are we, you know?
Yeah, if the question is about threat intelligence generally and vulnerability detection, there are a few ways in which we can do that, but the most common is through the content inspection capabilities that are in the NetWall product. So where we're looking at sort of edges of OT networks at the moment, this is where we perform our vulnerability detection. So NetWall is able to perform full content inspection for files that are moving across the unidirectional gateway. And we have a database of in excess of 33 million vulnerability signatures that are applied at the point where that data leaves the network. So the advantage here is that you have a cross-domain enforcement point for vulnerability propagation. And we're not tied to any one source of data. So some of these signatures come from Bayshore, some of them come from industry, some of them come from the manufacturers themselves. And there's a lot of detail behind how we do it. So for example, we can support YARA rules, we can support ICS cert vulnerability notifications. There's a lot of different capabilities that are built into the engine at that point in the product. So, yeah,
And
broadly, yes, it's available. Happy to talk about the specifics with the customer.
And a follow-up to that relates to the firmware-related vulnerabilities that are often reported, sometimes by vendors and of course by other services and security firms. But I think that would probably fall into the similar answer.
Well, I mean, there's two parts to it. So we are able to detect exploit attempts when there are known exploits in the world. We're not a scanner. So this is an important point. We do not actively scan the assets themselves because there's generally risk associated with that type of strategy. We do encourage people to, verify and update firmware releases whenever possible, but we recognize that that's not always easy. Scrutiny, for example, is a passive tool. OTFuse and NetWall are all passive as far as their interactions with other assets on the device, and we believe that that is a more repeatable and consistent safety strategy for assets.
Okay, great. There was a question related to DNS. Is DNS required to be enabled at SCADA machines? And that's almost verbatim. I can't interpret that properly. Is DNS required?
Well, Philippe can probably speak to it as well. I mean, internal DNS may be needed, and SCADA systems may look up their destinations by internal DNS. But if the question is about internet DNS, then no, we don't require any direct connection to any sort of internet-facing DNS lookups.
Okay, and we're coming to the end of our time, and we have one last question that's been asked. Is there any PLC hardening required for cybersecurity implementation? And this is a question that will have a very interesting answer because, part of what we're about is hardening the environment and the network communications. But is there any PLC specific hardening required?
Philippe, do you want to speak to that?
To get our solutions to work, there is no. Yeah, we could talk for hours about this. The short answer is no. The short answer is no, because precisely something like OTFuse is really designed to overcome the shortcomings of those older generations of PLCs, that do not have a security stack, integrated. So that's, if let's say somebody wanted to do I don't know, do some funny kind of connection to a PLC, that would be detected by OTFuse, and so the traffic would be dropped. And so because of that, I would be inclined to say, no, we don't really need to harden the PLC. However, in a general sense, if you can do some minor hardening, such as making sure that the password is not the default password, that basic stuff, then of course you're more than welcome to start with that, of course.
Yeah. Okay, and I would also add that we would tell you we don't have to touch your PLC to
Correct.
implement our solutions around it for the protection layers that are there. So, and he's right, if you could check your firmware updates or any further updates that your vendors like you to have at your PLC, that's always good guidance. We're at the end of our time, and it's good timing. There are a few questions for ATS to follow up, and we will follow up with those of you one-on-one where perhaps you didn't get a full answer or you need more information. And thank you again for attending. I'll turn this back over to Rahul.
Yes, thanks a lot, Catherine, for this good question answer sessions, and thank you to Toby as well as Philip for answering those questions. So I take this opportunity to thank you everyone who attended this webinar, and it was good to have you, and we look forward for your requirements and other things, and we'll closely work with you. So after this webinar, we'll be sending you the email with all details and contacts and everything. So it will be good in future to work with you. So that's it from my side. So we'll be closing the webinar session now. Thanks a lot, everyone, once again. Thank you.
Thank you.
Thank you.
Thank you.
Thank you.